This apparatus allows you to demonstrate all types of electrostatic and magnetic properties of electrons based on a CRT. Additionally, you can determine E over M. All of the power supplies, controls, and displays are located in one compact unit. There is a standard CRT. For magnetic deflection, there are a pair of Helmholtz coils for experiments that are perpendicular to the electron path, and there is a solenoid for experiments that are parallel to the electron path. It is all built in to this convenient storage device that has a lid so you can store this safely when not in use. The voltages can be controlled by 3 knobs: VK, VI, and VG. These are all selected independently of each other, but their voltages are displayed on the top digital display. The plates that are in the middle of the CRT can be independently adjusted in the VX and VY direction. These are selected independently of each other and displayed on the second digital display. You can also choose a VD, which gives you a horizontal line for aligning the tube properly. When investigating the external magnetic fields, you would turn on the switch on the bottom right, and the current through the corresponding magnetic device would be on the third digital display. If you're going to use the Helmholtz coils, you would adjust the knob that is labeled magnetic. If you are using the solenoid, you would adjust the knob that is called deflection. Both of these can be reversed by using the reverse switch that is to the left of the CRT. The knobs on the upper right help you zero out the X and Y direction. You want to make sure that the voltage across the VX and VY is 0, and then adjust the 0 for X and Y to get a centralized dot. Here we have the apparatus turned on and engaged, and I'm just going to click through and notice the top voltage is giving you the different voltages at the tube. Now, to make sure we have a central dot, I need to make sure my VX and VY are both 0. So this is the center display. So that's VX, that's VY, so they are both at 0. So now I'm going to go down and look in front and adjust these if needed to get a centralized dot. I have my central dot, it looks pretty good. I'm just going to adjust the Y, see how you can move this and get it right centered. Same thing with the X. Now that we're all set up, we're going to do an electrostatic deflection. So I'm going to adjust the X so it moves left and right. The Y moves up and down, and since the display has the voltage and you do have a millimeter scale on here, you can determine the voltage per millimeter. Well, I have the Helmholtz coils connected. The number of turns, the diameter, and the radius are all in the instruction manual. I have the deflection switch on, and I'm going to adjust the magnetic field with this knob. The current will be displayed on this bottom digital display. With the current and the coils, you can determine the magnetic field strength and also determine the angle of deflection. So here's a head-on view. I increase the current in the Helmholtz coil. It goes up. Now I'm going to use the reversing switch, so my current and everything will stay the same. It's just the direction will be 180 degrees from that. Here we have the setup using the solenoid. The connections for the solenoid are on the front. The knob for adjusting the magnetic field and the current in the solenoid is off to the side. That is being displayed on the bottom display. With this setup, you can investigate the ratio of E to M, but you will be getting a spiral as opposed to a flat, plane, circular orbit of electrons. As you change the magnetic field, you will be adjusting the pitch. Here is what the front of the CRT looks like. I'm going to make note of the current with the spiral in the position that it's currently in, increase the current until it comes back around again, and there it is in the same position but with a different current in the magnetic field. And using the number of spirals that you go through and the current at each one, you can use that to determine E over M. The only special maintenance that this unit needs is to make sure that you minimize and shut off the power every time you change the setup. If you are inserting or removing the tube, make sure the power is off and be gentle, because the pins that are connecting at the back are very small and can be bent easily. Once you get this apparatus in your classroom, you find out your students will be able to thoroughly investigate all the electromagnetic properties of electrons. This is a very comprehensive tool, and the instruction manual has all the specifications that you need, along with the background information.